These are the 4 important types of CPU scheduling algorithms are there. So please make a note of it. It is very, very important. If the CPU adopts this method, it has to wait in a queue for 18.75 milliseconds. That is the average waiting time of all these processes. It has waited from here to here 8 milliseconds. From year to year, again it has waited for some time. Hello and warm welcome to one and all. It is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's lesson, you will be taught about the scheduling algorithms. What is the meaning of scheduling algorithms? Yes, of course, there are different types of algorithms that is going to be adopted by the CPU to plan according to the requirements of execution so that each and every process is executed very well. By doing this, the efficiency of the system also increases. If that is the case, let me take you into the different types of scheduling algorithms. First one is first come first serve CPU scheduling algorithm. Second one is shortest job first scheduling algorithm. Third one is priority scheduling algorithm. Fourth one is round robin CPU scheduling algorithm. These are the 4 important types of CPU scheduling algorithms are there. So please make a note of it. It is very, very important. Very, very important. You will be questioned with any one of these questions, any one of these problems. If you observe the previous year question papers completely, there will be one question from any one of these for 10 marks. So please be careful and understand. First come first served scheduling algorithm. Jobs are executed on the basis of first come first served basis. Second one is easy to understand and implement. Third one, poor in performance as average wait time is high. If that is the case, let me write down the Gantt chart for this. See here, process P1 arrives first. What is the time taken to complete that? 0 to 20th second completely. That means 0, 1, 0 to 20th second completely. It is not from 1 to 20th, so 0 to 20th. So totally how many seconds it utilizes? 21 seconds burst time. Which is the next process? That is process P2 arrives and it requires 3 seconds to execute. So from 21, 22, 23 completely taken by process P2. That means 21, 22, 23. So totally these 3 seconds are consumed by process P2. So if 23rd second is completely taken, 24th second is the next available slot for P3. So 24th is the next available slot for P3. What is the time, burst time required for it? It requires 6 seconds. 6 seconds. So process P3 requires 6 seconds. Process P2 requires 3 seconds. So process P4 requires how many seconds? 30, 31, 32. So 30, 31 is completely consumed. That means 2 seconds. If you look at it, you will see that 2 seconds of burst time is needed for process P4. If that is the case, 20, 30, 31 is taken by P4. That is 2 seconds. So this is the strategy. This is the statistics we have. That is 21 seconds for process P1. So if that is the case, we have this operation. What is the time taken by this? 21 seconds. Till the execution of process P1, process P2 must wait. What is the time taken by process P2 to execute? 21 seconds. Process P3 to execute 24 seconds. Process P4 must wait for 30 seconds till the process P3 is executed. So 0 plus 21 plus 24 plus 30. What is the total time waited by processes in the queue? So it can be written as 0 plus 21 plus 24 plus 30, that is equal to 21 plus 24 is equal to 45. 45 plus 30, that is 75. That is divided by 4. What is the value of it? 4 ones are 4, 3, 5. 4 8s are 32.30 is there. So 4 8s are 4 7s are 28. So we have left with 2. 20. 4 5s are 20. So totally 18.75 milliseconds is the total average waiting time. That is the average waiting time of these processes in case of first come first serve CPU scheduling algorithm. If the CPU adopts this method, it has to wait in a queue for 18.75 milliseconds. That is the average waiting time of all these processes. Suppose if the CPU adopts any other algorithms like preemptive CPU scheduling algorithm, that is preemptive shortest job first scheduling algorithm, if I consider that which is the first job, shortest job, process P4, which is the next shortest job, process P3, P2, then which is the next shortest job, P3, next shortest job, ultimately it is obviously 21 seconds, that is of P1. If I write down in the form of this, 0 and 1 is consumed by what? P4. At the second, P2 begins. How many seconds? 3 seconds. 2, 3, 4, 5 completely. 2, 3, 4 completely. Then fifth second. From fifth second it begins with process P3. How many seconds? 6 seconds. 5, 6, 7, 8, 9, 10. Till 10th second it completes. 11th second it begins with P4. So 11 to 21, that is 31st second completely is utilized by P1. If that is the case, if I add up these terms, what is the value I am getting? I will not add this term because there is no other process waiting in this after this. So let me consider till here. 0 plus 2, 2, 2 plus 5, 7, 7 plus 11, that is 18. 18 by 4, how many processes are there? Average 18. 18 by 4. So 18 by 4 is equal to 4 4s are 16.20, 4 5s are 20, that is 4.5 milliseconds is the average waiting time. For the same number of processes, for the same set of processes, if the CPU adopts this preemptive shortest job first scheduling algorithm, it completes the execution of it in these milliseconds, that is 4.5 milliseconds. But if it had adopted the other one, that is the first come first served, it would have been taking these many seconds, 18.75 milliseconds. But in this case, since it has taken the approach of preemptive shortest job first scheduling algorithm, it requires at most 4.5 milliseconds to complete the entire process execution, that is process P1 to P4. That is the average waiting time of these processes in the queue. If that is the case, which is the next type of scheduling algorithm, please don't worry. I will give more number of questions on these algorithms so that it becomes familiar to you all while solving the problems. Next, we have two columns here. First column indicates the burst time and the other column indicates the arrival time. Process P1 requires 21 seconds, but it arrives at 0th millisecond. Please be careful with non-preemptive. Process P2 requires 3 milliseconds to execute, but arrives at first millisecond. Process P3 requires 6 milliseconds, but arrives at second millisecond. Process P4 requires 2 milliseconds, but arrives at third millisecond. Which is the process arriving at 0th millisecond? So process P1. What does the non-preemptive scheduling algorithm indicates? During the time of execution, if any other process comes in, no other process are permitted. If that is the case, let me see to that Gantt chart. See here. In case of preemptive, what happens? 0th second is completely utilized by process P1. But if you look at it, 0th second. At first second, which is that process that has arrived? Process P2 has arrived. But we require at the third millisecond, process P4 is arriving. And what is the time required? Shortest job. This is the shortest job. But this shortest job has not yet arrived. If it has not yet arrived, which is the process which has come earlier? at first second, process P2. But what is the time required? 3 milliseconds. So if that is the case, preemptive requires what? Preemptive requires to execute 1 more milliseconds for process P2. So process P1 is executed for 0th millisecond completely. In the first millisecond, process P2 arrives. So P2 must be executed for 1 millisecond. Then process P3 arrives at 2nd millisecond. So P3 must be executed for 1 millisecond. Then which is the next process which comes at? Process P4 comes at 3rd millisecond. So which is the shortest job? It has to be executed for 2 milliseconds. That means 3, 4. 5th millisecond it comes. Which is that process? Next process in the queue. We have completed the process P4. We have already completed 1 millisecond from this, 1 millisecond from this. We are left with 2 milliseconds of work, 5 milliseconds of work of P2 and P3. So if that is the case, P2 must be executed next, then P3 must be executed, then we will go to P1 in case of preemptive. That means we have from 5 to P2 2 seconds, 5, 6, 7th millisecond, P3 is taken. How many seconds it requires more? 5 more seconds are required. So 7 to how many seconds? 7 plus 5, that is 7, 8, 9, 10, 11th second. Till the completion of 11th second, P3 is executed. 12th milliseconds, P1 is considered here. How many seconds is already executed? 1 millisecond. So remaining 20 milliseconds it has to be executed. So P1 must be executed from here to 10, here to 20, we requires 31 milliseconds. So this is the Gantt chart. Please make a note of it. The Gantt chart is also very, very important. It carries a marks. Gantt chart. If you look at this 0 to 1 P2, then P4 arrives at 3rd millisecond, P2 at 5th millisecond, P3 at 6th millisecond, P1 at 12th millisecond and completes at 31st millisecond. If that is the case, what is the time required for P1 to execute? Please look at it here. P1 completed it at which millisecond? If you look at this, P1 waited till 12 minus 1 because initially it waited for 0th millisecond, arrived at 0, so it completed. So P1 is equal to 12 minus 0 milliseconds waited. Then P2 waited for how many milliseconds? P2 completed at 6th millisecond but waited till 5th millisecond. So 5 minus 2. 2 is the completion time. So 5 minus, please look at it, 5 minus 3. What is the meaning of this? If you look at this, P2, beginning of P2 is 5. What is the completion of this P2? 3. So 5 minus 3 is P2. 6. P3 begins at 6. Waits till 6th second. What is the completion of P3? Nowhere. 6 minus 2 we have. Then we have 12 minus 1 here. So we have found that 12 minus 1 is the first millisecond, first process. Second process P2 waits here 5 minus 2. Here it waits for 1 millisecond, 0 and 1, that is 5 minus 1, that is 4. But it has waited a long way from here to here. That means 5 minus 0 and 1, that is 2. We have 5 minus 1 milliseconds waited by process P2. If that is the case, let me rewrite this. If that is the case, process P3 begins at second 7. But what is the time scheduled for this process P3? How many milliseconds it has waited? It has waited from here to here 2 milliseconds and 1 millisecond completed. Then it has waited for completion of 6th millisecond. So 6 minus 2, that means 6 plus 2 is what? 6 plus 2, 8. But actually, what is the time taken to complete this task? 11th millisecond. If it is taking the 11th millisecond, what is the time of beginning of this waiting? This means 7th millisecond. 7 minus 2. That means 5. P3, 7 minus 2 is equal to 5 milliseconds waited. Then P4. P4 waited for how many milliseconds? 3 milliseconds. If that is the case, if you look at it, P1 has taken 12 milliseconds, waited. P2 has waited 4 milliseconds. P3 has waited 5 milliseconds. P4 has waited 3 milliseconds. If I take the average of these, that is 12 plus 4 plus 5 plus 3, that is equal to 12 plus 4, 16. 16 plus 5, 21. 21 plus 3, 24. 24 by 4. 4 6 are 24. 6 milliseconds. So, if preemptive shortest job first scheduling algorithm is used, it takes 6 milliseconds. What about the non-preemptive CPU scheduling algorithm? What about the non-preemptive CPU scheduling algorithm? If I consider the same question, P1 arrives at time 0, it has to complete the execution of that, because once it starts running, it won't consider any other priority. So, P1 must be completed. So, if that is the case, let me rewrite this diagram. Because it arrives at time 0, 0 to 21 seconds means 0 to 20th second. Complete 20th second is taken here. 21 second, which is that next process begins. By the time of 21st second, all of these process will be waiting here. So, which is the shortest job then? Process P4. P4 takes 2 milliseconds. So, if that is the case, 21, 22 is taken completely by process P4. So, 23 is the next thing. Process which is the next shortest job, 3 milliseconds, which is P2. P2, it has already come by this time, 23 millisecond. So, which is that P2? P2 requires how many seconds? 3 milliseconds. So, 23, 24, 25 is completely taken by this P2. So, 26th it begins with the next process. If that is the case, how many times needed for this? Seconds. P3 requires 6 milliseconds. So, 26, 27, 28, 29, 30, 31 completely is taken by this second. So, 32 begins next, but there is no other process to begin after this. So, if that is the case, what is the waiting time of this non-preemptive CPU scheduling algorithm? 0 is the waiting time for process P1. Process P4 waits for 21 milliseconds. Process P2 waits for 23 milliseconds. Process P4 waits for 26 milliseconds. So, totally it turns out to be the value which is equal to 21 plus 23 plus 26 plus 0, which is equal to 21 plus 23, 42, 44. 44 plus 6, 50, 70. So, 70 is the milliseconds, total milliseconds. So, 70 by 4 is equal to 4 ones are 4. What is the time required here? 4 ones are 4, 30. 4 sevens are 28.20. 17.5 milliseconds is the time taken with respect to non-preemptive CPU scheduling algorithm. Non-preemptive SJF CPU scheduling algorithm. So, next is the priority CPU scheduling algorithm. In case the priorities are assigned there, what is the time taken with highest priority? Then the process with same priority are executed in FCFS. Suppose if there are two processes P1 and P2 with the priority 2 and 2, then FCFS is considered. That means if process P1 comes first, then process P1 is considered for execution, then process P2 is considered for execution. Priority can be decided based on memory requirements, time requirements, or any other resource requirements. If that is the case, we have a burst time here. priority here. Which is the process which is having the topmost priority? First. That is, process P2 is having the first priority, process P1 is the next priority, P4 is the third priority, P3 is in the fourth priority. So if that is the case, P2 comes at first priority. If that is the case, what is the time needed? 3 seconds. 0, 1, 2 is completely used by this process P2. Then, which is the next in highest priority? That is P1. P1 requires 21 milliseconds. From 3 to 21 means for complete 23rd seconds is utilized by process P1. Then P4 begins at 24. P4 requires 2 milliseconds. So 24, 25 is completely utilized by P4. Then P6 begins at P3. P3 begins at the second, 26. So we have what is the time needed for P3? P3 requires 6 milliseconds. So 26, 27, 28, 29, 30, 31 is completely utilized by this process P3. If that is the case, what is the waiting time of this? 0 plus 3 plus 24 plus 26. That leads to 24 plus 26 is equal to 30, 50, 53. It is equal to 53. 53 divided by 4, that is equal to 4 ones are 4, 1 3. 4 3s are 12, 0.10. 4 2s are 8, 20. 13.25 is the milliseconds. Yes, 13.25 is the average waiting time if the CPU adopts the priority scheduling algorithm. There is one more scheduling algorithm called round robin CPU scheduling algorithm. What is the meaning of this round robin CPU scheduling algorithm? It requires a time quantum. Let me consider the same number of burst times for process P1, P2, P3, P4. What is the time quantum allotted? 5 milliseconds is the time quantum allotted. But what is the time needed for process P1? 21 milliseconds. So 0 to 4 completely utilized by process P1. So from 5th milliseconds, which process comes in? Process P2. But what is the time needed? Only 3 milliseconds. So it cannot wait for the next other processes. So what happens? As soon as it completes the process, P2 moves to the process P3. So 5, 6, 7 completely taken by process P2. So this is for process P1 for 5 milliseconds. Then P2 completes at 3 milliseconds, means 5, 6, 7 completely begins at 8 milliseconds. Which is that process? This process P3. How many seconds needed? 6 milliseconds. But what is the time quantum mentioned? 5 milliseconds. So it can utilize only 5 milliseconds. From 8, 9, 10, 11, 12 till 12th millisecond, process P3 executes. Then 13th millisecond onwards, it moves to the 4th process. That is, it requires only 2 milliseconds. If that is the case, but what is the time mentioned here? 5. But it won't take more time. That is, 5 milliseconds are not taken. Only 2 milliseconds are taken. That means 13, 14 is utilized by process P4. Then, as soon as the process P4 completes execution, then moves to the next P1. What is the time needed? That is, process P1 requires 2 milliseconds. That means 13, 14 is utilized. 15th begins with this. Completes at 14th complete milliseconds. Then 15th. We have P1. What is the time taken? 5 milliseconds. From 0 to 4, earlier it was taken completely. Now it is taking 15th to 5 means 15, 16, 17, 18, 19th complete second. That means 20th millisecond, the other process begins. Which is the next process that is not yet over? That is this process, process P3. P3 is remaining with 1 millisecond. So P3 is executed for 1 millisecond, 20th second completely. 21st second it begins with the rest of the process, that is only left with this process, that is process P1, 21, 22, 23, 24, 21, 22, 23, 24, 25 completely utilized by process P1. Then 26, then again we have 26 to 26, 27, 28, 29, 30th complete is taken by process P1. We are left with 1 more millisecond. So 30 is this. 31 begins with another process. 31 completely is taken by this process P1 once again. So it completes all these processes like this. With this, what is the waiting time of process P1? 31 milliseconds. Waiting time of process P2, 5 milliseconds. Waiting time of P3, 8 milliseconds. P4, 13 milliseconds. I will add up these terms. 31 plus 5 plus 8 plus 13. That is 31 plus 5 plus 8 plus 13, which is equal to 31 plus 5, 36. 36 plus 8, 44. 44 plus 13, 47, 57. So 57 by 4 is equal to 4 1s are 4, left out with 1, that is 1 7. 4 4s are 16, left out with 1, point, it becomes 0. 4 2s are 8, left with 2. So 0 indicates 4 5s are 20. 14.25 milliseconds are needed to execute in case of round robin CPU scheduling algorithm. If that is the case, please see to it here. P1 waited till 31st millisecond. P3 has waited till 20th millisecond. 20th millisecond. Not till 8th millisecond. Because it has waited from here to here 8 milliseconds. From here to here again it has waited for some time, right? So it has to be considered here. Not just 8, it is 20th millisecond. 20th millisecond. So if that is the case, 31 plus 5, P2 completed 5, waiting time 5, plus P3 20th millisecond, plus P4 13th millisecond. So totally it turns out to be the value which is equal to 31 plus 5, 36, 36 plus 20, 56, 56 plus 10, 13, 66 plus 3, 69 milliseconds. So 69 milliseconds divided by 4, which is equal to 4 1s are 4, 2 9 is left out with 2 9. 4 5s are 20, 4 6 are 24, 4 7s are 28. 4 7s are 28. So what is the time needed then? 1 point, what left out with 1, 0, 4 5s are. So 17.5 milliseconds. Not even 11 milliseconds, it is 17.5 milliseconds taken by the round robin CPU scheduling algorithm. I will give you more number of examples on first come first serve CPU scheduling algorithm, then on priority scheduling algorithm, then on shortest job first, preemptive shortest job first scheduling algorithm, then on non-preemptive CPU scheduling algorithm, finally round robin CPU scheduling algorithm. At least I'll give 5 questions from each of these scheduling algorithms, so that it becomes a practice for you guys to complete the process of scheduling algorithms very neatly. Thank you very much. Thank you one and all.